A Harvard professor has documented 13 characteristics of an interstellar comet that are so rare, their combined probability is less than 1 in 10 billion. The scientific community is divided. What does this mean? In 7 days, on December 19th, the interstellar comet 3I Atlas will reach its closest point to Earth. Then it disappears from our solar system forever. Dr. Avi Loeb, professor of astrophysics at Harvard University and former chair of the astronomy department, has spent the last few months documenting 13 properties of this object that deviate from normal comets. Not 1 or 2 anomalies, 13. Some of these anomalies have probabilities of less than 0.5%. When considered together, their combined probability is less than 1 in 10 billion. The question isn't whether 3I Atlas is unusual. The question is, what does unusual mean for an object that has traveled through the galaxy for 4 billion years? Let's go through the facts without sensationalism, but also without premature conclusions. Loeb divides the anomalies into 3 categories. Let's start with the 6 major ones, those that cannot simply be explained as coincidence. The first anomaly is what Loeb calls the Jupiter coincidence. On March 16, 2026, 3I Atlas will pass Jupiter at exactly 53.445 million kilometers. This is interesting because this distance almost exactly matches Jupiter's hill radius, which is 53.502 million kilometers. The hill radius is the region where Jupiter's gravity dominates. The probability of this match is 4.004%, or 1 in 25,000. Loeb points out that this precise approach was enabled by the non-gravitational acceleration that 3I Atlas displayed near perihelion. At the Lagrange points L1 and L2, precisely at the hill radius, orbital corrections and fuel requirements would be minimal. The second anomaly involves the timing of planetary encounters. The arrival time of 3I Atlas was extraordinarily well-tuned. The object came within tens of millions of kilometers of Mars, Venus, and Jupiter, and arrived precisely when it was unobservable from Earth at perihelion, its closest point to the Sun. The probability of this timing is 0.005%. The third major anomaly is rapid brightening. Near the Sun, 3I Atlas brightened faster than most Oort cloud comets at similar distances. Even more unusual, the object appeared bluer than the Sun. Normally, dust would redden the scattered sunlight. The surface should be much cooler than the Sun's 5 to 800 degree photosphere, making it redder, not bluer. This blue glow implies an internal heat source hotter than the Sun's photosphere. The fourth anomaly is extreme negative polarization. 3I Atlas shows extreme negative polarization of reflected light, a phenomenon never observed in any known comet, including 2I Borisov. The probability of this is less than 1%. This unusual polarization could be related to the surface composition, possibly involving materials that differ from natural comet dust. The fifth anomaly involves orbital alignment. The retrograde orbit of 3I Atlas, moving opposite to the direction of the planets, is aligned within 5 degrees of the ecliptic plane. This makes access to all planets significantly easier. The probability of this alignment is 0.2%, or 1 in 500. The sixth major anomaly is the direction toward the WOW signal. 3I Atlas arrived from a direction that coincides within 9 degrees of the famous WOW signal from 1977, the strongest potential extraterrestrial signal ever received. The probability of this is 0.6%. 6 anomalies, each with a probability under 1%. But there are 7 more to discuss. Perhaps the most visible anomaly is what Loeb calls the anti-tail, a jet pointing toward the Sun, not away from it. Normally, comet tails point away from the Sun because solar radiation and solar wind push gas and dust outward. But high-resolution images from the Hubble Space Telescope, taken both before and after perihelion, show a jet directed toward the Sun. Loeb explains that micrometer-sized dust particles would have been blown away by solar radiation. The anti-tail cannot consist of normal comet dust. It must contain larger, heavier material that resists solar radiation. The orientation of the anti-tail changed at perihelion, and this is not an optical illusion from perspective distortion, as occurs with some comets. The gas envelope around 3I Atlas contains only 4% water by mass, while water is normally the main component of comets in our solar system. Instead, the cloud is dominated by carbon dioxide ice. The nickel-to-iron ratio resembles industrial alloys more than natural comet material. New data show structural symmetry with a statistical significance of 5 sigma. This means the probability that this symmetry is random is about 1 in 3.5 million. 3I Atlas doesn't look like a loose conglomerate of ice and rock. It shows internal resilience and a coherent outer shell. Stacked images from late November show jets forming 2 thin, ruler straight lines perpendicular to the Sun object axis. They create an X shape with the tail and anti-tail. Loeb describes this formation as similar to a bow wave of smaller objects separating from the main body. 13 anomalies, Each one individually might have a natural explanation, but together, what do they mean? And here's where the scientific debate becomes as interesting as the object itself. Dr. Jason Wright from Penn State University, a respected planetary scientist, published a detailed analysis of Loeb's anomalies. His conclusion is that of the 10 original anomalies, planetary scientists are really only interested in 4: the high nickel content, the extreme polarization, the low water content, and the rapid brightening. Wright argues these are exactly the kind of anomalies you'd expect from a new type of comet, not from a spacecraft. Loeb responds with a provocative question: how can anyone claim to be an expert on interstellar objects when the sample size includes only 2 previously known examples, Oumuamua and 2I Borisov? He compares the situation to the failed search for sterile neutrinos in particle physics. For decades, anomalies in experiments led scientists to postulate a hypothetical new particle. 2 major experiments searched for it. Both failed. Nobody called the search for sterile neutrinos nonsense, not even after it failed. But the idea of a technological origin for interstellar objects is immediately dismissed as unscientific. Why? Loeb writes, "The foundation of science is based on the humility to learn, not on the arrogance of expertise." When 3I Atlas was discovered in July, comet experts immediately said, "This is an ordinary water-rich comet." Loeb calls this AI-like behavior. They only reflect the datasets they were trained on. But science should work differently. It should take anomalies seriously, not ignore them. The proper response to alternative interpretations isn't to ignore them, but to refute them with data. The controversy around 3I Atlas isn't just about a comet, it's about how science is communicated and how we handle the unexpected. Let's be honest, we don't know what 3I Atlas is. It could be a completely natural comet, the first of its kind we've observed from another star system. Its anomalies might simply show us how different comets can be when they've traveled through the galaxy for 4 billion years. It could also be something we've never seen before, a new type of astronomical object that breaks our categories of comet and asteroid. Or, and this is the possibility Loeb leaves open, it could be something technological. Here's the important insight. All 3 possibilities are scientifically valuable. If 3I Atlas is a normal comet, why does it show 13 anomalies? What can we learn about the formation of planetary systems in other parts of the galaxy? If it's a new type of object, that expands our understanding of the universe. And if, only if, it's something technological, then that's the most important discovery in human history. Loeb is right about one thing. The consequences are so significant that we shouldn't rule out the possibility before we have all the data. On December 19th, 3I Atlas will pass Earth at 270 million kilometers, as close as this object will ever come. Telescopes around the world are ready. The data we collect in the coming weeks will help answer these questions. You witnessed Apollo, you saw Voyager's launch. You know that the greatest discoveries often come from the unexpected. 3I Atlas, whether comet, unknown object, or something else entirely, reminds us that the universe always surprises us. The 13 anomalies are real. The debate about what they mean is also real, and that's good science. In 7 days, we'll know more. Until then, 3I Atlas remains what science should be, an open mystery. What do you think? I'd love to read your thoughts in the comments.